Hello everyone. First of all, I wanted to thank you for watching this video on the topic of Zero Trust Security on the AWS cloud. By nature, technologies in IT are ever evolving. While hot topics like AI, IoT will remain to be focused by startups and enterprises, cloud computing is becoming the backbone of other technologies and services. Further, on the cloud, security is the essential part for cloud service providers, but also the customers with their systems on the cloud or intended to move their systems to the cloud. I would like to touch upon Zero Trust Security, which is one of the interesting labels in the security area. Again, if there are any mistakes in this video, please let me know and I will be much appreciated. Here is a brief intro of myself. I have more than 20 years experience in the IT field, focusing on digital emerging tech and data analytics. I've been involved in various industries such as financial service, healthcare, and high tech. Most importantly, I am a big promoter of cloud technologies with great enthusiasm. I'm certified on AWS Solution Architect Professional, AWS DevOps Engineer Professional, and AWS Specialty of Database, Data Analytics, Machine Learning, and Security, as well as Microsoft Azure Solution Architect Expert and Security Engineer. You are very welcome to connect me on LinkedIn by scanning the QR code on the bottom right corner. Today, the enterprise working environments become more complex and diversified as they operate hybrid environments, including on-premise, remote infrastructures, and cloud services. The network perimeter is no longer fixed as first, users including employees, service providers, and third parties may work remotely. Secondly, different devices such as company-issued devices, personal devices, mobile devices, and even IoT devices may be applied. Furthermore, connections may be requested from different locations like in the office, at home, at the airport, or in a cafe, and with trusted or untrusted public or private internet. Enterprises can no longer rely on traditional perimeter-based security model, which separates the internal and external networks with the network perimeter using firewalls, VPNs, and considering internal networks as trusted, while external network as untrusted, to let good guys in and keep bad guys out. They need a new security model that can effectively adapt to the complexity of the modern environment, embraces the mobile workforce, and protects devices, applications, and data wherever they are located. Commonly used traditional perimeter-based technologies like VPNs and firewalls are working in a similar fashion that separates networks into internal and external with network perimeter. I will take VPN as an example to illustrate why it is giving a loophole to the attackers. Due to the COVID situation globally, many people are working remotely with VPNs to connect to their enterprise's environment. The traditional VPN provides a direct, trusted connection right past all perimeter defenses. Consider VPN as a safety guard or a gatekeeper. A legitimate user can connect to the internal network with a simple authentication against the VPN using username and password, just like the guy in the cartoon telling the security guard who he is and his purpose of visiting this community, and the VPN as safety guard will verify if the person whom he is visiting is actually live in this community and then let the visit in. But what could occur when network security is compromised? They may hack the public Wi-Fi, which the employee used in a cafe, and steal his VPN credentials and pretend to be Tom, or they can disguise a valid connection like, hey, I am Tom, I have been here earlier, to cheat the VPN. Once the attackers bypass the VPN, the internal network has no more protection mechanism that is fully trusted, and attackers may steal or damage the enterprise data and applications, scan and attack other digital assets horizontally. With that being said, now I'm going to speak about Zero Trust security. The core concept and basic principle in the world of Zero Trust security is never trust and always verify. Zero Trust security is not a new concept. It was first proposed by Stephen Paul Marsh back in 1994 in his doctoral thesis on computational security. And a lot of other security experts have successfully contributed to the enrichment of the concept. However, it took about 2 decades for Zero Trust architecture to become prevalent, driven in part by increased adoption of mobile and cloud services. By August 2020, the final version of Zero Trust architecture was published by the National Institute of Standards and Technology. Now let's come back to the question, what is Zero Trust security? Steve Schmidt, VP of Security Engineering and CISO at AWS, mentioned in his speech of Zero Trust on AWS. Zero Trust is a conceptual model and an associated set of mechanisms that focus on providing security controls around the digital assets that do not solely or fundamentally depend on traditional network controls or network perimeters. We can interpret the same in plain English as Zero Trust security is a security framework requiring all users, no matter inside or outside the enterprise network, to be authenticated, authorized, and continuously validated for security configuration and posture before being granted with any privilege or keeping access to any applications or data. Zero Trust security assumes that there is no traditional network perimeter. Networks can be local, in the cloud, or a combination or hybrid with resources anywhere as well as workers in any location. 2 dimensions are always considered when we talk about Zero Trust security. The first dimension is network. Zero Trust security considers breaking the system down to smaller logical components and implementing tighter network segments or packet-level controls, and use gateway or proxy technology to enforce a new type of trust boundary. The second dimension is identity. Zero Trust security requires authenticating, authorizing, and continuously validating the identity no matter if it is human-to-machine communication, like human being using PC, tablets, phones to access web applications, or a machine-to-machine communication, like software to software. After understanding the general definition and the 2 dimensions of Zero Trust security, let's take a look at 2 use cases from AWS lens, which talk more concretely on how AWS enforces authentication and authorization in all circumstances. For fun and better digestion, the use cases will be carried out in a short cartoon.
One leading use case is customer interacts with AWS Cloud using AWS APIs. For instance, when a customer tries to log in the AWS account, a request will be sent to the AWS Cloud. On the AWS Cloud side, after receiving access request, it will authenticate it and authorize the request and send it back to the customer. Only after getting the authentication, customer could log in the AWS account successfully. Each action the customer interacts with AWS Cloud will create signed API request, which is authenticated and authorized every single time at rates of millions upon millions of requests per second globally. Also, AWS provides multi-factor authentication, extra layer of protection on its security. Multi-factor authentication is a dynamic verification mechanism. After receiving request from the customer, AWS will send verification code to the virtual multi-factor authentication devices, a software app that runs on a phone or other device. Then, customer need to type in the verification code to get access to the AWS website. Each verification code must be unique. A customer cannot use a verification code from other users' virtual multi-factor authentication device to authenticate. AWS service interacting with each other. When each AWS service interacts with each other, it also need to be authenticated and authorized. AWS Identity and Access Management (IAM) is the tool to manage access to AWS services and resources securely. For instance, when we need EC2 to have access to put object to, get or delete object from S3 bucket A, we need to set S3 bucket policy in the IAM role and attach the role to the specific EC2 instance. IAM check the role policy of the EC2 instance which is having S3 put get delete object permission so that it can upload objects to, download and delete objects from S3 bucket A. Each signed API request is authenticated and authorized every single time. A request without required permission will be failing in the IAM authentication when validating the required permissions against the IAM role which the EC2 instance attached. For example, EC2 sends put file to S3 bucket B with get object only access permission, it will be rejected. Even though S3 and EC2 are both AWS services, they have no inherent trust. IAM authenticates and authorizes the incoming calls for all AWS services. In this way, each AWS service could only interact with each other if it has required access permissions. It protects the resources and services internally on the AWS cloud.
From AWS's perspective, instead of relying on individual components, Zero Trust security can only be accomplished by unifying multiple needed services together. First of all, every device, user, and network flow must be authenticated, authorized, and continuously validated. AWS multi-factor authentication can be used for AWS accounts, individual IAM users, or even control access to AWS service APIs. Next, AWS recommends only allocating necessary access to the users, no more and no less. It limits the scope of permissions by applying the principle of least privilege with the micro-segmented resources using AWS identity and access management roles and policies. Permission boundaries can be achieved using a managed policy to limit the maximum permission that an identity-based policy can grant to an IAM entity. AWS also requests to have the data encrypted both at rest in any sort of storage and in transit between storage or services. AWS Key Management Service (KMS) and other integrated services or protocols such as HTTPS, SSL, and TLS can be applied to encrypt and protect the data. AWS security groups can be used to provide highly dynamic, software-defined network microparameters as virtual firewalls to provide host-level security for web and application servers. It controls access to each of the individual instances. To further protect the workloads, service, and the data, enterprises can use AWS Private Link, VPC subnet, gateway, endpoints, and the security groups along with network access control list to divide the environment down to the segments to prevent horizontally spreading attacks when they gain access to one segment. Enterprises can log, monitor, and audit all traffic with AWS CloudTrail and AWS CloudWatch, and set up matrices and alarms for the aspects of critical resources and systems. The last but not least principle from AWS on applying Zero Trust security is not to apply any standard of list of services in order to claim the accomplishment of Zero Trust security. Again, the architecture should be considered by making trade-offs between 5 pillars of AWS well-architected framework, as we talked about in my last video. If you are interested in it, please find it as AWS well-architected framework white paper quick walkthrough on my channel. Now I wanted to illustrate how AWS services and components as part of the Zero Trust architecture to prevent attacks. First of all, let's take a look at one simple architecture on AWS. Let's say one customer has 2 AWS virtual private clouds, VPCs, across 2 availability zones. There is a VPC peering set up between these 2 VPCs. In front of VPCs, there is an AWS CloudFront as the content delivery service. It has AWS Application Load Balancer ALB and AWS Network Load Balancer NLB to spread loads within and across multiple availability zones, and AWS EC2 Auto Scaling Group for dynamically ramping up and down the computational power based on the demand in time. From the backend, data will be stored to and retrieved from the AWS RDS database. Indeed, this architecture does meet the requirement of AWS well-architected framework. But further, let's see how we can harden the architecture by applying Zero Trust security for better security protections. First, we could add an AWS WAF service in front of AWS CloudFront. AWS WAF service helps to enforce the rules to the CloudFront distribution and effectively filter malicious traffic such as SQL injection. Next, as AWS Application Load Balancer, ALB is using a public address to keep it discoverable from the internet, we can also add another WAF service to apply rules as the mitigation. Furthermore, between internal components, additional filtering can be implemented for local input validation. We can impose continuous authentication and authorization between different tiers, such as API signing. Another well-known threat over the internet is DDoS, which refers to the attack on a server, service, or website that floods it with internet traffic. AWS Shield is designed to recognize and protect against DDoS attacks. On the other hand, AWS Guard Duty watches the customer's environment and looks for anomalies outside and inside the VPCs. AWS recommends a series of services combined together for real-time monitoring and abnormal handling in a Zero Trust security model. Proper customized metrics and monitoring mechanisms can be implemented to achieve the traceability of traffic flows. Adopt the power of machine learning and apply AWS CloudWatch anomaly detection to recognize unusual patterns and identify potential security threats. Trigger real-time reaction such as AWS Lambda by using CloudWatch alarms to notify Amazon Simple Notification Service topics. The AWS Lambda function will help to suspend, detach, and isolate the instance identified with issue, and analyze the same later. The principle of adding the above-mentioned AWS services is to protect each component at microservice level instead of treating the entire architecture as a whole. Additionally, least privilege encryption with AWS KMS should always be taken into consideration. However, on the other hand, while we implement these extra AWS services on top of the initial architecture, we have brought more cost, complexity, and operational overhead to the enterprise. So while thinking about zero trust security, the enterprise should wisely evaluate the organization's needs by referencing the AWS well-architected framework and make balanced choices on their architectures. Again, I wanted to provide you the basics of zero trust security and how AWS interpreted the same on its cloud. You are encouraged to read through the articles listed here for further understanding of this concept. With that said, I am completing this video for now. I hope you have learned something, and I will keep helping you on your journey of exploring cloud computing. Thank you.